It was quite hard, wasn't it? It was quite a mess. We worked it out previously by working out the time to the top of flight and then separately working out how long it's going to take to fall from there, adding those two times together and then using that to work out what the range was. Quite a complicated process for working out what T1 was, the time to the top of flight, and then to work out what T2 was. There is a simpler way, although it does involve a bit more mathematics. And let me just say now that if this means nothing to you whatsoever, then this video is probably not for you, and I'd go back and watch the other video a few times, and that's the way to solve it. But if you can see that is pretty simple, something you've seen before, then we're going to have a go at using that in solving this a slightly different way. We're going to use this formula here, but again, just considering the vertical or the y component. So that Ry equals Uyt plus a half g, because we're talking about gravity, t squared. Now let's have a look at our equation here. What is the change in vertical displacement before it hits the water? What's it got to do before it hits the water? Well, it's got to fall 100 meters, and downwards is minus. It's got to go down 100 meters. So at the point where it's 100 meters below where it started from, that's when it's going to hit the water. So what we can say is that Ry at the final point is going to be minus 100 meters compared to where it was at the start. That's pretty useful. Okay, now our initial y velocity, we worked out what the component of that was. It's 30 meters per second. We know what this is. So let's rearrange this equation as g onto t squared plus uyt minus ry equals 0. We're going to rearrange it in the form of a quadratic equation. X squared, something x squared plus x plus something equals 0. And that's what our general form up here is going to help us work out what t is. So we're talking about in terms of t. So this is going to be g onto t squared plus uyt minus negative 100. So that's going to give us plus 100 equals 0. Okay, so this term here is our A term, this term here is our B term, and this term here is our C term. And we're going to stick that into the general form of a quadratic. Let's get rid of that now we've used him, and see if we can solve this in a little bit quicker kind of time. Okay, so it's minus b plus or minus, so we have to just grind our way through the mathematics here. So it's going to be minus, so t, the total time for the flight, is going to be equal to minus uy, that's b, plus or minus. Now what we have to do is have to calculate each possibility, and only one possibility is going to have a physical reality. B squared, that's uy squared, minus 4 times the A term is g on 2, get that out of the way a bit, for AC, so times 100, all on 2 times A, which is g on 2. Okay, so we've got ourselves there. We can simplify a few things here, so that's just going to be g. We can simplify those to there, to the 2. Okay, so now it's going to be minus uy, so it's going to be equal to minus 30 plus or minus the square root of 30 squared minus 2 times, don't forget it's minus 9.8 times 100, all on minus 9.8. And that's what our total flight time is going to be equal to. And if you're able to follow me down at this point here, you're going to have no trouble substituting that in and calculating and finding out which of the two times is possible. Just as an aside on that, the wrong time that you'll get will actually be the time down here before the cannonball was shot, because it assumes that this is a complete parabola. And then the second time, which will be some sort of positive time. So if you get a negative time, it means that, theoretically, if it had been shot, in negative time, it could have come from down there. There's only one physical reality that you need to worry about, and that's the positive time solution. So that's a slightly more elegant, although mathematically more complicated way of solving probably what's going to be about the most difficult projectile motion equation they're going to throw at you in the HSC.